In this video, I will talk about the iteration pi parts in calculus. Okay, so from calculus 1, you have learned about the product rule in how to find the derivative of something, right? So, what is the product rule? The product rule is d of u v over dx, right? This uv is the function of x. Okay, so the derivative of uv equal to u dv over dx plus du over dx v, right? You have learned this formula in calculus 1, okay? So the question is, what if I integrate both sides, right? So if I integrate both sides like this integral is gonna be uv, right? And this one is u dv plus the integral v du, right? So next, uv equal this one, right? So u dv, I'm gonna move v du to this side, so this equal to uv minus v du, right? So this is the formula of the iteration pi part, right? So next one, I'm gonna talk about the priority. So for example, you have the integral and you don't know, you have to choose u or what you should choose dv, right? So the priority in choosing u. So choose u in this order. So L A T is, this is a trick, right? A trick to remember. So L is log function, right? A is algebraic. For example, like polynomial function, okay? And T is trig function, right? And E is exponent function, right? So you're going to choose U in this order. Remember this order, okay? Okay, so now we're going to go through an example. Evaluate the integral x to the 4 natural log of x dx, right? So we're going to apply the iteration paper, okay? So due to the priority, I have to take a picture of the priority. Okay, so due to the priority, choose U in this order, okay? So this one is the algebraic function, right? This is a algebraic function. And this one is logarithm function, right? So due to the priority, because L is higher than A, right? This is L and A. L is higher than A. So we're going to choose L is the logarithm function. So U equal to natural log of X, right? And dV equal to X4 dx, right? U is this one, and V is X4 dx, okay? So we're gonna have we're gonna differentiate U. So we're gonna have du equal 1 over x dx, right? And v equal to, we integrate to find the v, right? So v equal to x5 over 5, because the antiderivative of x to the 4 is x to the 5 over 5, right? So next one, we're gonna apply the iteration per part, okay? So this integral equal to uv, right? Uv, so natural log of x to 5 over 5 minus integral from uv minus v du, right? So it's equal to x5 over 5 multiply 1 over x dx, right? So this is equal to, this one is x5 natural log of x over 5, right? Minus this one is the integral x4 over 4, because x cancel out, right? So this equal to x5 natural log of x over 5. And the antiderivative of x to the 4 is x to the fifth over 5, right? So it's equal to x fifth over 5. 5 multiplied 5 is going to be 25, right? Plus c. Okay, so this is the integral of this function. Okay, so go to the next example. Evaluate this integral e to the x sine of x dx, right? So first we have to choose which one is u and which one is dv, right? Which one is u and which one is dv, okay? So this one e to the x is exponent function, right? And sine is the trigonometry function, right? So our reality is L A T E, right? So E is exponent function, so E is the last, right? And T is the third. So T is higher than E, so our U gonna be T, right? So T is trigonometric function, and the trigonometric function in this formula is sine, right? So U equals to sine x, right? And dv is the remaining, so this is e to the x dx, right? So we're gonna have we differentiate both sides, so we're gonna have du, right? And the derivative of sine is cosine of x dx, right? And dv equal to e to the x dx, right? So v equal to the antiderivative of e to the x. So the antiderivative of e to the x is gonna be e to the x, right? Itself, right? So the integral equal to uv, right? So sine x multiply e to the x, right? Minus v du. So this is e to the x. Du is cosine of x dx, right? So this integral equal to this one. But we're not done yet. We have to find the integral of this one. So the integral of this one is kind of tricky because we cannot apply the derivative. We cannot apply the integration rule directly. We have to do the integration by part one more time. Okay. So next one, I'm gonna find m and dn. So I have to identify m and dn. Okay. So as our reality, LATE. So e to the x is exponent is e, and cosine is t, right? T is higher than e, so we're gonna let m equal to the trigonometric function, and dn equal to e to the x, right? E to the x dx, sorry, okay. So we differentiate m equal cosine x, so this is dm equal to negative sine of x dx, right? And we find n. So n equal to the antiderivative of e to the x, right? So it's equal to e to the x equal to itself, right? So that equal to, okay, sine x multiply e to the x, so I just rewrite it, okay? Negative. I'm gonna put a parenthesis for, okay? So the integral of e to the x cosine of x dx, right, is equal to mn. So this is e to the x cosine of x, right, mn, right, minus the integral n dm, right? So this is e to the x negative sine of x dx, right? Close parenthesis. Okay, so next one, e to the x sine of x. So I distribute the negative side in here. So I'm gonna have e to the x cosine of x, right? Minus and minus is positive, right? Because we have a minus right here, so this is negative e to the x sine of x dx, right? So this integral equal to e to the x sine of x. This integral equal to the initial integral, right? So we can see this one and this one, right? This one is the same. right? So I'm gonna move this one right here. I'm gonna move this term to the left hand side. So negative become positive. Right? It's equal to, rewrite it down. Minus e to the x cosine of x, right? So this one is the same, right? So this is equal to 2 the integral of e to the x sine x dx, right? Equal to, it have the same e to the x, so I'm gonna take e to the x out. I factor e to the x out. It's equal to cosine of x, right? So I'm gonna divide it both sides by 2, so it's equal to sine x dx equal to e to the x sine of x minus cosine of x divided by 2, right? So this is our final answer. Oh, I forgot plus C. Okay. So if this video is helpful, don't forget to give me a like and subscribe. Thank you so much.